Señoras y señores, muy buenos días. La Universidad Técnica Particular de Loja, RESPECT y Naturaleza y Cultura Internacional les dan la más cordial bienvenida al Simposio ecuatoriano-alemán Biodiversidad frente al cambio global, consecuencias para los ecosistemas, un espacio que permitirá debatir sobre los desafíos que se enfrentan en la búsqueda de proteger y conservar la biodiversidad en el contexto del cambio global. Luego de 3 años retomamos el Simposio Internacional Ecuatoriano-Alemán de Investigación, que por más de 20 años, gracias a la cooperación entre DFG, Naturaleza y Cultura Internacional y las universidades del sur del país, han venido realizando importantísimas investigaciones en los bosques tropicales de montaña, generando una fuerte interacción, aportando al fortalecimiento de la formación de cuarto nivel y entregando resultados científicos de mucha importancia a nivel mundial. Actualmente el programa DFG RESPECT ha ampliado su espectro de investigación también hacia los bosques secos del país. El objetivo principal de este simposio es presentación y debate de los resultados del proyecto RESPECT DFG de la investigación ecuatoriana sobre el cambio global en la biodiversidad y el funcionamiento de los ecosistemas. Difundir los resultados a los estudiantes ecuatorianos interesados en la biodiversidad y sus dinámicas, como también al público en general. Así también identificar vacíos en la investigación y desarrollo de ideas para el futuro, para intensificar y fortalecer la colaboración a través de nuevos vínculos, creando redes de cooperación científica. Saludamos en esta mañana a las autoridades que nos acompañan. Doctora Silvia González, vicerrectora de investigación de la Universidad Técnica Particular de Loja. Profesor George Bendix, vocero del proyecto RESPECT DFG. Y biólogo Felipe Serrano, director de Naturaleza y Cultura Internacional del Ecuador. De la misma manera, extendemos un fraterno saludo al público que se une a esta transmisión en vivo a través de nuestras cuentas oficiales, utpl.loja, Naturaleza y Cultura Ecuador, UTPL Eventos e Investiga UTPL. Para dar inicio, tendremos la intervención de la doctora Silvia González, vicerrectora de investigación de la Universidad Técnica Particular de Loja, quien dará la bienvenida al presente evento. Bienvenida, doctora Silvia.
Muy buenos días. Agradecer la organización, tanto el Grupo Alemán como también a Ecuador. De la UTPL, agradecer a todos los que han participado en este evento, que es uno de los primeros que se realizan en la universidad, ¿no? Internacionales. Así que nos alegra mucho recibirles. Siéntanse en su casa. You're welcome. Así que, pues, desear que estas jornadas sean, pues, este simposio sea pues trascendental, ¿no? En el tema que se va a hablar sobre biodiversidad y cambio climático, y en el que podamos encontrar pues claves en las que podamos, de lo que se ha hecho, pues seguir desarrollando. Darles también la bienvenida a las universidades ecuatorianas que nos visitan, a la Nacional de Loja, la Universidad de Cuenca, la Politécnica Nacional y a la Universidad de la SUAY. También agradecer su contribución a INABIO y a Naturaleza y Cultura Internacional también por su participación y también por las aportaciones en este simposio, así como a todos los profesores investigadores de la Philips University of Magdeburg, el Instituto de Tecnología de Karlsruhe, la Universidad de Frankfurt y de Goethe y la Universidad de Múnich. Nos alegra mucho que podamos acoger este evento y que pues ser los anfitriones nos alegra mucho, y también desear que sea muy fructífero, que podamos compartir conocimientos, ponernos al día, ¿no? en este campo, y sobre todo inspirar a nuestros estudiantes a seguir soñando con la posibilidad y el horizonte de conocer más de la naturaleza, de aquello que nos aporta, lo importante que es cuidarla y también sacar lo mejor posible para las comunidades que viven en estos sitios, y que lo que se esté haciendo y lo que se esté mejorando en estos ecosistemas frágiles también será ¿no? También habrá beneficios para toda la humanidad, ¿no? Para cuidarle de la mejor forma. Así que todos los esfuerzos que hagamos por conocer y cuidar de nuestra naturaleza será bueno para nosotros, para las siguientes generaciones, para dejarles un mejor mundo, ¿no? Un mejor mundo en donde se pueda acoger a la humanidad y darles mejores condiciones a las personas, ¿no? A nosotros, a los que estamos viviendo ahora y a las siguientes generaciones. Creo que esta conciencia ambiental va más allá del impacto que estamos ahora generando, ¿no? Sino pensar y tener perspectiva de futuro, ¿no? Y trascendente, ¿no? De que lo que nosotros hacemos ayuda o perjudica o hace daño a alguien más, no solamente hoy, ¿no? Sino también en el día de mañana. Así que agradecerles pues también el viaje que han hecho. Yo sé que nunca es fácil llegar a Loja, no es un sitio de paso, ¿no? Incluso el vuelo de ayer de la tarde de Quito se regresó. Así que, bueno, pues el esfuerzo de venir a Loja ya es para agradecerles. Así que desearles todo lo mejor y que los trabajos del simposio sean memorables y sean pues trascendentes para el desarrollo de la ciencia en este campo. Muchísimas gracias y muy buen día.
Agradecemos la intervención de la doctora Silvia González. Seguidamente escucharemos al biólogo Felipe Serrano, director de Naturaleza y Cultura Internacional del Ecuador, quien realiza la presentación de este simposio. Bienvenido, biólogo Felipe.
Muchas gracias. Doctora Silvia González, vicerrectora de investigación de la UTPL, profesor George Wendix y doctora Nina Farwick, Respect Program Leaders, distinguished authorities, guests, partners, colleagues, students, and friends. Let's try a brief speech in English and Spanish. I would like to start saying good morning to everyone, and once again, welcome to Loja. For Nature and Culture International, the Ecuadorian-German program has been part of our foundation as organization. We were born together in Ecuador in 1996. We have grown progressively, and this alliance has lasted for more than 26 years. Many results of this collaboration can be listed, but we must highlight the important scientific production, the linking of more than 20 Ecuadorian and German universities, and the training of hundreds of scientists to understand and conserve the wonderful mountain forest. We are going through an unprecedented environmental crisis. Nevertheless, in what often feels like an avalanche of bad news on the environment, the good news is that the future is entirely in our hands. And so there is no more important a moment for us to be speaking about biodiversity and climate change. Because what we do or don't do in the next 10 years will determine the fate of our planet. This is not a small matter. In fact, we have never been in more important and critical moment for the human species. We don't have time. Scientists, politicians, governments, civil society actors, we must accelerate our work. We are very excited to meet again in this auditorium. The symposium brought us together every year. The pandemic stopped us, but today we feel again the value of this alliance for research and conservation. Many thanks to DFG and Respect Program for reactivating this event, and sponsoring the research. The same to the NCI staff for permanently maintaining and improving the San Francisco and La Ipuna scientific stations. Gratitude to UTPL for hosting the symposium, and to Universidad Nacional de Loja, Universidad de la SUAY, Universidad de Cuenca, Universidad Politécnica Nacional, and Instituto Nacional de Biodiversidad for their important collaboration. And a very special mention to all the researchers for their commitment to science and their commitment to tropical mountain forest. Para Naturaleza y Cultura Internacional, el programa de investigaciones de ecuatoriano-alemán ha sido parte de nuestros cimientos como organización. Nacimos juntos en el 96 y tenemos más de 26 años funcionando. Son muchos los resultados de esta colaboración, pero debemos destacar la importante producción científica, la vinculación de más de 20 universidades de Alemania y de Ecuador para entender y conservar los extraordinarios bosques de montaña. Estamos viviendo una crisis ambiental sin precedentes. A pesar de las malas noticias en el sector ambiental, la buena noticia es que el futuro está enteramente en nuestras manos. No ha habido un momento tan necesario como ahora para hablar y actuar responsablemente sobre la biodiversidad y el cambio climático. Lo que hagamos en los próximos 10 años determinará el futuro del planeta y de la especie humana. Entonces, no tenemos tiempo. Los científicos, los tomadores de decisiones, debemos acelerar nuestro trabajo urgentemente. Por eso estamos muy entusiasmados con la reactivación del simposio, que tuvo que detenerse por la pandemia, pero hoy estamos sintiendo nuevamente el valor de esta gran alianza académica. Nuestra gratitud a la DFG, al programa RESPECT, por reactivar el evento y por patrocinar las investigaciones, al personal de NCI por mantener las estaciones científicas de San Francisco y La Ipuna. Muchas gracias a la UTPL por organizar y ser el anfitrión del simposio, y a la Universidad Nacional de Loja, la Universidad de la SUAY, Universidad de Cuenca, Politécnica Nacional y el Instituto Nacional de Biodiversidad por su importante colaboración. Les deseamos éxitos en estas jornadas. Gracias.
Agradecemos la intervención del biólogo Felipe Serrano. A continuación tendremos la intervención del profesor George Bendix, vocero del proyecto RESPECT DFG. Estimado profesor Bendix, bienvenido.
Okay, unfortunately, I have to start again. I'm sorry. Okay, but it's very good to see you here. I always also can apologize so that I cannot talk in Spanish, as always. I should do it, but after 30 years, I still haven't learned it in a good manner. So here we are back. Sorry for the delay. Esteemed Vice Rector of Research, Dr. Silvia Gonzalez, esteemed authorities, dear students, dear colleagues, dear friends. So on behalf of the Research Unit Respect, I would also like to extend a warm welcome to you all to our Ecuadorian German Symposium on Biodiversity in the Face of Global Change, Consequences for Ecosystems. First of all, it's a great pleasure and it's my concern to especially thank UTPL for their support in hosting this symposium and also, of course, supporting the research units over all the time. So, as we already heard, it's a great joy to see you all in person. After the difficult years of the COVID pandemic, we are grateful to have the opportunity over the next 2 days to discuss our progress and our scientific questions. And I can just say that we are still here clearly underpins one point. Our close and long-standing ties in science are stronger than a pandemic. So that's very important. And so we are here again. That's great. However, of course, we are confronted with various other global crises, including the aggressive war of Russia against Ukraine, but we must not forget the severe global problems of biodiversity loss and climate change mankind is still facing. To better understand these complex processes and trade-offs in the global socio-ecological system under global change, the European Union has recently launched a challenging program for the next decades to produce a digital twin of the Earth, which shall combine cutting-edge Earth system and world models. And yeah, that's what we are doing in Respect. So our problem perfect aligns to this mission by generating a new land surface model through a joint effort of our German Ecuadorian consortium of bio and geoscientists. And let me say, as one of the oldest members of our consortium, I'm really proud to look back on our successful collaboration in the past, and that is already set over 3 research units, 2 bundled programs since 1997, all funded by the German Research Foundation, DFG, and the Ecuadorian universities, and that was great. Since then, and also that is stressed, countless research papers and books are jointly written, and many skillful students are primed and boosted in developed scientific and leading skills. And meanwhile, if I'm looking into the room, some of them are leading the universities here. And I'm looking around, I see a lot of professors from all universities which started their career in one of these programs we conducted jointly. And I guess that is a really great success. And the network was very interesting. It started, of course, with NCI as the initial enabler for research here in the mountain rainforest. But the universities of the first hour were UTPL and UNL, and we can still remember that when the program started, the UTPL biological department, which is one of the excellent departments now at UTPL, wasn't existing. So it was elaborated together with these programs. And also, I guess this is a great success. Yeah. So, as already was stressed, the network has grown and grown with the universities of Cuenca, and I'm very, very glad to see you here, University of Cuenca, University of Azuay. And also it works now, it grows with universities in Quito. And of course, finally, we have to thank INABIO. Without their help, the research was not possible. Almost 30 years, you said it. So if we end this research unit, maybe we have reached the 30 years almost. And this is a long time, particularly for a DFG project, which is an institution, the DFG, devoted to short-term funding of basic research. And continuous funding in the same research area over almost 3 decades is really exceptional. It's really exceptional, and that reveals the trust of DFG and the reviewers in our joint research. And that is also a great success. Our endeavor is really the long-lasting series of broad research programs in the domain of ecology, which is continuously funded by DFG. And this is a good thing, because we have discussed it several times. If we are talking about research and global change, that is not a matter of 3 years. So we need long-term research and funding. And so we are very grateful also to DFG. And before we starting with the scientific program, I would like to convey greetings from DFG, from Dr. Maike Teschke, the head of DFG Biodiversity Expert Board, and also from Dr. Halm. Most of you are knowing him. He's the head of the Department of Cooperative Research with Latin America. Yeah, and the world is changing, not only climate change and ecology and biodiversity. So with the new world order that we are apparently facing in near future, international collaborations with Latin America has to be strengthened more and more. That's becoming more and more important. And I can say DFG is working on that. Dear ladies and gentlemen, with this, let us start the symposium now as an inspiring think tank to pave the road towards joint future research activities in our great consortium in support to the people of Ecuador, of course, and beyond. Thank you.
Agradecemos al profesor Bendix y de esta manera damos inicio al Simposio ecuatoriano-alemán Biodiversidad frente al cambio global, consecuencias para los ecosistemas. Iniciamos en este momento con la primera conferencia de la mañana, para lo cual doy paso al moderador Baltasar Calvas.
Okay, hello everyone, also from my side. My name is Nina Fabik. I'm together with Jörg Bendig, the speaker of Respect Research Unit. And it's my pleasure to introduce the first speaker from the UTPL, Carlos Ivan Espinosa. We'll start a talk about global change and chronic disturbance and multiple threats in the dry forest. So the floor is yours, Carlos Ivan.
Good morning with everyone. First, it's a pleasure for me to start the symposium. I am going to talk about global change and chronic disturbance, multiple threats of the dry forest. Well, one of the main characteristics of the dry forest is the high precipitation seasonality of this forest that is the origin, the dynamics in these ecosystems and the different adaptations of the species that live in this forest. The dry forest in the neotropics is forming different nuclei of the dry forest along the neotropics, and one small area of the dry forest in the Ecuador is the Pacific Equatorial region. This region is the small formations, vegetal formations in this area, and this area have a highest dissimilarity with other nuclei. This is very, very important, but additionally, the dry forests have a unique biodiversity. In this forest, we have around 20% of the endemic species in different groups of biodiversity. But unfortunately, we are losing around to the 50% of this coverage is loose, and the remaining 40% is highly fragmented and have high vulnerability. But only the 6% in this forest is protected. Up to those problems, we have had the climate change. Climate change is a serious problem in the diversity in general, but in the dry forests, in these ecosystems that have high stress, maybe implied a greater risk. One possibility of one response to this risk is that species change in the distribution, the species distribution. But we don't have historical information about the occurrence in this the species, and we don't know if this change in this distribution. So, how to assess the impact of climate change? Where we develop a process to evaluate the tendencies in the new records in well-studied species like birds, and we used the 46 new records in the last 2 decades in the dry forest, and using this method for try to see what is the response of the species, the new records. It's possible that these new records are originated by the global change or climate change. We have that 11 species show evidence of the climate, the change in their distribution as consequence of the climate change. But what is the problem with this change? The problem is that the change in the species distribution maybe act in concert with other drivers such as deforestation. In this context, we evaluated the contribution of the 2 main drivers of the area loss, climate change and deforestation, and we developed models in the current and the future distribution area for 70 forest-tree species. And we evaluate the range, the change of range for climate change and deforestation. Our results show a reduction of the area of the distribution for 10 species, and for 7 species, the area of distribution increased. Additionally, we found that the rate of loss of the area of distribution is higher by deforestation than for climate change. But additionally of this problem, we found that in 5 species, the front of advance these 2 processes, deforestation and climate change, are coincident. But for 12 species, the front of advance is the opposite. This means that areas that are availability for climate change are deforested. This is very concerned with this species. But are these responses the same with other groups? For a sensitive group as amphibians, we evaluate how vulnerable these species are to the climate change, and we define future changes in distribution, directionality, and habitat availability at the new localities. We found that the most amphibians increase the distribution area, but we found that mismatch between the future and current areas, which implies a displacement of the habitat. Although the area increase, this area increase in other direction. The areas show displacement. When analyze the habitat availability after deforestation, we found that in general, the proportion of the remaining area is maintained. The species, the area, the remaining habitat is maintained. But for some species, we found that important loss of habitat availability for these two species here and here. The two different scenarios show that a loss of the habitat availability in the future. Well, the first conclusion is that climate change and deforestation are reducing the availability of habitat for the species. These two drivers often act synergically, increasing the negative effects in the species. Unlike other tropical forests, dry forests face additional problems. Many of these problems are related to the chronic disturbance. Two of the activities most important in this area is the selective logging and livestock. These two affect or origin the chronic disturbance. And these activities cause the forest degradation. The forest degradation, as consequence of forest degradation, we can find that the remaining forests are in different levels, states of degradation. We used the states and transition model for try to check what is the states in the dry forest, and this model allows us to know what is the states, the transitions between these states, and to the possibilities of the recover these states. We found that in the dry forest, we found three different levels of degradation: semi-natural, shrub dominated, and arid land. These three different states are characterized by richness loss and change in the structural composition. Additionally, we found a simplified state. This simplified state is characterized by few species and are the consequence of the regeneration from shrub-dominated state. We found that different forest states are the result of different histories and intensities of forest use, and each type or state requires the application of different recovery actions. Well, but does this really happen? This is STM, the State Transition Model, is a theoretical model. We try to see that this really happened in the field. Here we evaluated 30 indicators of pressure and dry forests in 3 different provinces of Ecuador. Our main idea is using the pressure indicators, try to check what is the effect on structural indicators, and use this the significative structural indicators for define forest stage. And finally, with this forest stage, try to check what is the effect in compositional indicators. We found a significant reduction in the richness around this gradient, and this reduction is most important for 3 species than for shrub. We also found important change in the properties of the soil. For example, in the carbon characteristics, we found that a reduction of the carbon stored in the soil. And for some indicators of functionality, the soil functionality, like different enzymes that involucrate in the dynamics of different processes. Well, it's clear that the disturbance reduce the richness of the plants in the dry forest. But what are the pathways? What are the pathways through which anthropogenic pressure modifies species richness? We using the structural equation models to evaluate both direct and indirect effects in the species richness. We think that the disturbance can affect directly richness, for example, eliminate some palatable species, for example, or can change the density of trees, and this can change the microenvironmental conditions that can affect the richness. We used data from 60 localities of the southern Ecuador, and our results show that the loss of richness is an effect of the direct and indirect effects. But the indirect effects are more important than indirect effects. These effects is most important for trees where the disturbance, the loss of richness is more indirectly than directly. The second conclusion, forest degradation generates a significant loss of biodiversity and modifies functional process. Understanding the process is fundamental to recovering and conserving these threatened ecosystems. Our next steps, with this information as baseline, we are starting some surveys that allow us understand what are ecological factors involved in the establishment of good species and what are consequences of chronic degradation on this process. We try to study biotic and abiotic filters in the recruitment of good species. We are using two different areas that study this topic. The first one is the Arenillas Reserve, where we have 9 hectares of the plot, the permanent plot. Here we start the study in this area. And the other area is the Zapotillo province, canton, where we have this gradient of degradation. Here we, right now, we are concluding implementation of exclusion, this type of exclusions around this gradient. And here we try to focus in the experiment for evaluate the effects of fungus and insects in the recruitment in the good species. That we expected that these two fungus and insect change around this gradient of degradation. Well, for take home, landscape scale pressures generate multiple impacts on biodiversity. This situation could worsen under climate change scenarios, and at the local level, chronic degradation of dry forest remnants leads to change in the microenvironmental and regulatory process. This reducing plant diversity and generating and cascading effect on other biological groups. Thank you.
Thank you very much, Carlos Ivan. We have time for one quick question, if we have the microphones somewhere in the room. So Eike has a question, but I don't know where the microphones are.
Muchas gracias para la charla, Carlos Ivan. I have one question. For the first part of your talk, you showed that, the species distributions obviously change under climate change. I was wondering, you showed an example for amphibians. You probably also looked at different species. Are there particular winner and loser species in the tropical dry forest under climate change?
Yes. We expected that it's possible that some species are introduced in the dry forest, but really the first work where we here this 11 species that we found that it's possible that change the distribution really are species that are arrive to the dry forest, not are the species that the dry forests are changed at the other areas. You understand? So these 11 species are new species in the dry forest.
Okay, thank you very much. I think we have to continue to keep our time. So the next speaker is Darwin Pucher from the UNL, and he will talk about the advances in the study of wood anatomy and tropical dendrochronology in southern Ecuador. The floor is yours, Darwin.
Good morning, everyone. For me, it's a pleasure to give this talk. There are authorities, professors, students, friends, and all people present here. In the name of the Universidad Nacional de Loja, I would like to present now a new topic. I will talk today about the woods. Yeah? It's how in the last 5 years we have advanced in the study of woods, that is wood anatomy and dendrochronology. As you see, we have worked in the southern Ecuador, in 3 specific forests, that is the dry forest, Andean forest, and humid forest is in big view. And at the moment, we have worked almost with more than 103 species, and all of that very well dated and with good collections. Most of the species are broadleaf and some 5-tree coniferous. What we are doing in our laboratory, we have 2 laboratories. One is of dendrochronology. In this, we are working more in macroscopic wood features. And also in other laboratory is in the microscopic wood feature, is in the wood anatomy laboratory. And of course, that is with the help in the cooperation, mainly with the German university, like the VIVO University. Also, we are doing some basic studies about the chemical properties of the woods. And what we are doing is to collect many data of each 3 species. Almost we are 141 features of each 3 species. Yeah? That is, for example, in physical, organoleptical, and anatomical features. For example, we have in the physical properties from humidity, density, shrink, and contraction of the woods. For the organoleptic features, from odor, color, weight, and also very specific details we take over each wood that we have in the collection. In the wood anatomical feature, of course, we work with the IAWA normative. This is international IAWA normative, and we have almost 200 features. But in our laboratory, for example, we don't work with all, but most of them we are working. For the chemical composition of the wood, we have a very basic feature like cellulose, lignin, ash, and extractives. And this is, of course, that is all our work, not only me, is with many colleagues and students that we are working together. And in the dendrochronology, we are dating the rings, for example, with methods from prepare the samples, to measure the sample, the rings, and finally to make a statistic analysis. We have tested a new method to check the density of the wood. For example, that is the blue intensity. Normally this is working on the coniferous 3 species, but now we are trying to see how it works in the hardwoods. And of course, we work also on stable isotopes for 3 rings, and the idea is to take each very well dated rings and to extract the alpha cellulose, and we measure like carbon 40, carbon 20, different isotopes of carbons, and also oxygen. But of course, in cooperation with other universities, we send the samples to make these measurements. We haven't done that in our university. And the main results that we have is more like to make a wood classification. we are trying to make the wood classification of our 3 species. For example, we make some dendrograms, clusters, to see how they are close together, and that is in the base of all these more than 100 features. For example, this is working with physical properties, organoleptic and anatomical features that we're working to build us. And we classify, for example, in 4 very defined groups. For example, the cedros groups, because the porous is something that are big, and also a very small group is the balsas, because all of them have a light density, guayacanes with a heavy density, and also laureles with semi-heavy density, for example. If we talk, for example, the guayacanes group, to make this group, we try to find the common features of all these 3 species. And for example, all these 3 species have this same feature. For example, all are more than 70 density, of course, and the organoleptic properties, for example, all are light odors, are darks, for example, heavies, and we try to find the common features of all these 3 species to classify in this group, for example, the Guayacan group. Also, we are focused more in the future for the wood identification from the wood anatomical features. For example, this is Guayacan. These are from the Bosque Seco, Androanthus chrysanthus, Androanthus bilbergi. And it's very hard to know at the first view which 3 species. Then we, for example, make a characterization of all these woods, and we find very specific features that are very good to differentiate the 3 species. For example, in Androanthus chrysanthus, we have the already are more than two or three series. But in bilbergi, it's very clear there are 1 series. And this is a very specific, very small feature, but only with this we are, for example, sure that this is not the same 3 species. Also, we try to find how the wood density, for example, is related with other features, and we found that the basic density, for example, is with the fiber, is very related with the parenchyma, for example, and we have also with the color, is not here, yeah, but we try to find the density is related with which other feature, for example. We are working also with the quantitative wood anatomy. This is together, for example, always in cooperation with the University of Erlangen, with the Professor Achim Breuning, and we are trying to find how is the change in each ring, in each year, how, for example, the vessels are changing. We make some statistical comparisons to see how the trees differentiate, how the 3 species have very well differentiated between them. And also, we are working in the hydraulic conductivity, that is also in cooperation with Professor Jürgen Homaya. We have 2 master students, and we are trying to see, for example, how is the distribution, density, and the size of the vessels to calculate the hydraulic conductivity. In other side, here we are working a new project in the trees of the Loja city, and also with a student of forest engineer of our university. And here we have an example, for example, of the most common tree from Loja city. Yeah, and we make a sampling in the north, center, and south of Loja to see if the same species are in the three sites, to see if they have some difference. And of course, we found some difference between three species. For example, this big is Grevillea, Grevillea robusta, and we see how they are different between them. And in the quantitative wood feature, we found, for example, with these vertex diagrams, when they are connected, that means that all are the same. But we found, for example, only one feature in the diameter of the vessels. We found that the trees that are in the north of the city are very different in the quantitative feature with the center and south of the city of Loja. We can see that Loja is a small city, but even the center are different with the wood anatomical features. And we collect the some botanical samples, and we make also anatomical cuts, and we have to try if all of them are different tree species. And it's very interesting to find that the pith, the shape of the pith, is a good feature to see which tree species is. For example, we thought that this is a clusia, but when we saw that it's not clusia, it's rubiacea, and we see very different shape of the pith. And we are trying to find key features to tree species differentiation. And in the other field of dendrochronology, of course, we are working a lot with many trees, and this is a new chronology that we're working. Is Juglans neotropica, is more than 100 years. This is in El Tundo, and that is how we are working in our dendrochronology laboratory. And we can see, for example, how is the growth dynamic of the Juglans neotropica. This reach more than 200 years, and this is continue growing. They don't stop, and we don't know how many years needs to be old. For example, this is a big trees that we have collect samples, and they are growing, always growing. A difference of other tree species, for example, here we have Cedrela, and in two different places, and we can see also the same tendency, the same growing, and in the other more dry place, for example, we see that the biological rotation age for these trees are in almost 16 years. And that is the difference how the trees are growing. I think this is other lines, but are very light, we can see very well. But this is how is the growing of these other tree species. And we compare also the data of tree growth with the climate. For example, this is in Mera, is with the Cedrela nebulosa, and we compare how they are growing and how the precipitation is going. In this case, is in close to Napo, and there are not a good correlation between rain width and precipitation. But for example, with temperature, we found a very nice correlation with these tree species, and we have a good R values. And this is, for example, a good species to see maybe for climate reconstruction. In some years, we have a very good correlation, but in others, it's a little low. And we have other project. We have to, because it's very difficult to identify which is true rings and false ring, we try to make artificial rings because we put in a greenhouse some trees and we put a stress. And we put, for example, 2 weeks of stress, 4 weeks, and after that we try to test how was growing in this period, how are the cells, and to find, to check which is true and false ring. And this is how we work also the result with blue intensity. And also, we date the rings, for example, Juglas and Cedrela, with carbon 14, and they are very well dated. That means that our trees are annual rings. And this is how it is more in wood anatomy than dendrochronology. For example, the last year we could collaborate with other colleagues and was possible to publish in Nature. Also, we have published in Frontes other papers, and also we like to also publish in Spanish in our local journals. And what we are doing also, we work in some workshops. In the last 2 weeks, we have the help of the Professor Broining. We make a dendro course with the students of the Universidad Nacional de Loja. And also, we have with the master program, the Climate and Biodiversity Master Program, we have this interchange, for example, with the Professor Jürgen Homaya in the institutes, when our students were able to know new knowledge about the wood quantitative features. And what are our future projects? We are developing some web application with the informatic school of our university. And now, for example, we are almost ready with this application of urban trees. This is called Árbol QR. In this application, we put all of the data of each tree, for example, of the city of Loja. We put ecosystem service, phytosanitary status, tree growth, and wood structure. And also together with the municipio de Loja, we try to put a label in each tree with a QR code. And with the mobile application, we can just read and we get all information of each tree. For example, this is how we have sampled all trees of the city of Loja. More than 5,000 trees we have collected, and we are almost ready to put public these applications. And also, we are working to put all this wood information in a virtual siloteca. This is the Siloteca Virtual of UNL. At the moment, we have more than 100 tree species, most of them hardwood than softwood. Yeah? And this, I would like to show you how it is building. And we try to make a platform to put all of the woods, for example. We put features. We have, these are all of the three species that we have at the moment. And also is how we can add a new tree species, for example, in this web platform. We just select the family, for example, the site where this was collected, and also we put the code. And we can add also the picture of these three species. Yeah, here I would like to show an example. For example, Acacia macracantha. All of the collection that we have is in digital, and just we are going to show here in this web application. And also for us, it's very important to have the botanical sample in high resolution, and also the sample for the wood also. And this also we put all the anatomical image, and when the people who want to know how is this wood, just can access and to see these features. Yeah, in different size, for example, in different cuts, can be cross section, radial section, or tangential section. And finally, we have, for example, the wood sample, where the people can see all of that. And that is what we have worked in the last 5 years. And also, if you want to check our scientific production, we have many posters in this session that we have worked together, not only in this laboratory, but also with our master program. We have some works that I invite you to visit this. Thank you very much.
Thank you very much, Darwin. Unfortunately, I have to postpone the questions to the coffee break, and we have to continue to keep the schedule. And our next speaker is Rolando Sellery from the University of Cuenca, and he will talk about land use change impacts on the hydrology of the Paramo ecosystem. So the floor is yours, Rolando.
Good morning. I'm really happy to be here today, that we are starting again this annual symposium that has been a permanent feature for our activities in the University of Cuenca. So we have been coming to this symposium, I think, from 2009, 2010, and really very happy to be here again after the pandemic. So what I'm talking today is about the land use change impacts on the hydrology of Andean paramos, which has been one of the main research lines that we have had in the University of Cuenca since the beginning of our studies. So this is a general picture of a paramo ecosystem in which we have different hydrological response units. For instance, we have pajonales, tuso grasses, we have polylepis forests, and also wetlands. But wherever you go in this high altitude ecosystem, you're going to find also that the human activities are going up mountain every time more and more, and we have several crops in the area, pastures, non-native pastures, and also exotic forests. And one of the main questions that people have in the Interandean region is, what will be the impact of this transformation of the ecosystem on water resources? Taking into account that, for instance, in the case of Cuenca, almost 100% of the drinking water comes from the Paramo ecosystem. And indeed, there is a very strong link between vegetation, land use, and water. And as in the first presentation that we have this morning, we could see this transition between almost native or unaltered ecosystem. There are different states until a very high degradation. In this case, the wetlands are completely dry as a preparation for cattle activities or agricultural activities. So the question is how this transformation will affect the availability of water. And in terms of water quantity, water quality, but also this variability along the year, because we can have different degrees of impact along the year, depending on the rainfall regime. So in the past, we have already studied the impact of pine plantations on the hydrology and also agricultural activities. But there was a new concern for the water authorities in Cuenca. Basically, what was the impact of extensive and intensive cattle grazing? Because one of the normal activities, cultural activities, is that during the dry season in which the pastures become drier, limited in the lower elevations, people take the cattle to the upper parts of the headwaters, and they are eating all they can of the pajonales. So even within the Cajas National Park, this is a very big concern, because every time more and more there are cattle herds entering the park, and this is one of the main sources of water for Cuenca. So in the past, there has been some studies regarding this topic, but all of them studied very small scale, small plot scale, and also during very short time periods. So the results were not really conclusive for the needs of the drinking water company. And so two questions were arising at the moment. That was the impact on this cattle grazing on water resources at the hill slope scale? And also very important, what was the recovery time after the cattle is taking out of these grasslands. This is because, as is a seasonal practice, they didn't know if the time after the cattle was brought back to the lower lands and waiting 1 year for coming back again, it was enough for the vegetation to recover. And there was a lot of different perceptions. Some people thought that maybe less than a year the grassland was already recovered. Other people said maybe it's more than 1 year. So there were different points of view. So what we did is an experiment at the hill slope scale. And what we did is just pass from this natural condition, so we remove only the vegetation, to understand what was the impact on water fluxes and also the impact on the energy balance. So, of course, when you talk about the impact of cattle, if there are just too many cattle in a single place, the soils are going to be destroyed. But in our case, what we did is only remove the vegetation to isolate the effect of vegetation alone. So we didn't touch the soil, so the soil remained unaltered, and we were able to isolate the effect of vegetation and water. And of course, there were many hypotheses before, so these changes in vegetation, of course, they are going to change, there are going to be a big change in interception, but also evaporation, because there are no vegetation anymore, but also in transpiration, because there are no plants anymore to transpire water, and at the end also infiltration. So all these aspects are going to influence in soil water content and also the net radiation. So this was the schematic, this is the schematic a scheme of the experiment. So we installed in 4 different places soil moisture sensors and also an air radiation sensor in 2 parallel gradients in a big plot in a hill slope, and compare the impact between these two hill slopes. So in 2013, more or less, we implemented the sensors, and we lived it for 3 years, more or less, until we had a good baseline of the behavior of the 2 hill slopes. And at the end of 2016, we performed the experiment. So we cut all the grass, and then we measured the recovery, the impact on energy and also on water. So this is how it looks. Our hill slope is in our ecohydrological observatory in Churucay, and this is the native vegetation, the pajonal. And so here we were preparing the experiment. But first, we installed the sensors at different depths. In the upper part, the soils were very thin, so we had only 2 sensors, and in the lower part, we were able to put 4 different sensors at 4 different depths. And this is a picture of how it looked after the vegetation was removed. We can see already from this picture that the experimental plot looked more brighter than the native vegetation. So here was a bit darker. So this was already something we didn't expect, because at the beginning we thought it was going to be completely black, and that would have a big impact on the net radiation, but it was not the case. And this is a close-up of how was the vegetation on the control plot and how it was in the experimental plot. After a couple of weeks that were already some rain events, we can see already the vegetation was starting to recover, so getting greener. And this is the team who was in charge of the experiments, and I'm glad that this was in 2016. So I'm glad that already 3 of them are here, and one of them, Paola Montenegro, who did his master thesis as part of this experiment, and also she continued doing her studies after. So what was the impact on soil water content? So I'm going to show you only this picture. What I'm showing you here is, in this box plot, there are the difference between the previous condition, previous to the experiment, and the condition post-experiment. So you remember we had two plots, 2 transects. Yeah? So, and we were measuring the upper, middle, and lower elevation of the transect. But of course, previous to the experiment, there could be some differences between the upper parts, the lower parts, and parts on the bottom. So naturally, there could be some differences, and that's why we have here, for each position and for each depth, we have these two box plots. So in one case, we were comparing the previous condition between the experimental and the control plot, and after the experiment, also comparing the conditions between the experimental and the control plot. And what we can see is that in most of the sites, the impact is very limited or negligible. So the soil water content remain almost unaltered, with the exception of the upper part and 10 centimeters, the most superficial part of the plot is the only site in which you can see really strong differences in soil humidity. So this means that the different components of the water cycle, the infiltration, the interception, evaporation, were canceling out and more or less giving the same result at the end. But we wanted to see also, this picture is kind of a static picture of all the period. This is what I'm showing you here, only the first 10 months after the experiment in this comparison, because this was the period in which the soil humidity was going to be most affected, because once the vegetation grow, this effect would be totally canceled out. But we wanted to see if this grade of wetting and drying of the soil was also affected, and this is what I'm showing you here. So for each plot, I'm just showing you 3 examples. For the upper part, 25 centimeters depth, the lower part, 35 centimeters depth, and also in the middle part. I'm comparing the time series of both measurements comparing the control transect with experimental transect. And in the black line is the conditions previous to the experiment, and the green line, the condition post-experiment. And what we can see from here is that in some places, the dynamic of soil water content was not affected. So basically here, the two slopes are the same. So there was very little impact in this place. But in other places, you could see that the slope is very much different in comparison to the pre-experiment. And this means that the dynamics of soil wetting and drying was heavily affected. And indeed, 70% of the sensors showed significant changes in these soil water content dynamics. So this with regard with the soil water content, but what about the energy balance? And basically what we're doing here, remember, is because we wanted to know the impact or the recovery time. So we wanted to know how to measure that recovery time as well. And we had one hypothesis that if we measure the net radiation and all the components, maybe that was going to be a very good indicator of the recovery time. So something not subjective, but really based on measurements. And this is what I'm showing you here. So this is the albedo measured between both a comparison between the treatment plot and the control plot before the experiment. So basically the same. And after the experiment, during the first 3 years, in which we can see the first year the difference became very noticeable. And what we already saw in the picture, that the albedo in the treatment plot was much higher because become brighter. It's what we see here. And then in the 3rd year, the difference became also negligible. This can be probably seen easier or easily in this graph. Here I'm showing you the difference, the simultaneous difference between the observation of albedo between the treatment plot and the control plot. So we can already see that previous to the experiment, indeed, it was not perfectly the same. There was already some differences, but very close to 0. And then the moment we performed the experiment, we have this very high increase in the difference is because the albedo in the treatment plot was much higher. And also the dynamic, you can see the difference is very highly variable, let's say, until a given point in time in which the difference becomes almost constant and remain like that. So in this way, we were able to identify that the time to recovery was around 1.75 years after the experiment. So what conclusions can we have from this experiment? First, on soil water content, is that the impact, as I'll show you, in the mean soil water content was basically negligible. So this, in general terms, this means that the overall contribution of the water that is draining on this plot was the same that the water that was draining in the control plot. But the dynamics were really affected, particularly during the first 10 months, after which this difference became negligible again. The recovery time for vegetation was 1.75 years, and we also can conclude that albedo is a good an objective indicator of grass recovery. There are open questions from this experiment. We couldn't complete the experiment. One was, what if the paramo is subject to annual overgrazing? Because, as you remember, we performed one experiment and we waited until full recovery time. But the normal practice is that we have a yearly, this yearly practice of taking the cattle to the paramo. So we don't know yet, because we have to perform the experiment yearly and see if this impact becomes stronger with time as well. And the second question is, what if soils are altered? In some places there are just too many cows in the same place and the soils really become destroyed. And this we didn't measure, so this is also a question that we cannot answer yet. What else do we have in the pipeline? We have another study that is also emblematic, I think, for the region, because people were concerned about what is going to happen with climate change. And you know, we have the highest forest in this ecosystem is the polylepis forest. And people always are thinking, shall we do reforestation or afforestation with polylepis, replacing the pajonales or not? What's going to be the impact of that? So we were able to find a polylepis patch in which we can measure all the water cycle, all these variables that are mentioned here. We installed this experiment before the pandemic, so we have already analyzed all the impact, all the differences between the hydrology of this polylepis forest in comparison with the pajonal forest. But this study I will show you next year in the next symposium. So I thank you very much for your attention.
Thanks very much for this interesting talk. We have time for one quick question, if there's any at the moment. No, otherwise, as we started 15 minutes late, we will continue with the next speaker. That's Edwin Zarate from the University of Azuay, and he will tell us about his work on the ecological patterns of diatom communities in high tropical mountain andin streams in the context of global change. And while he's approaching, I will then also announce that we will kind of extend the coffee break by 15 minutes so that you still have time to get a coffee after Edwin's talk. Thanks very much.
Thank you very much for the invitation, and I am happy to be here. Today I want to share the preliminary result of my research that call it Exploring Ecological Patterns of the Atom Community in High Tropical Mountain Andes Stream in the context of the global change. We choose the diatoms because the diatoms are important components at the base of the trophic change and nutrient recycling of aquatic ecosystem. Therefore, it is important to understand how the structure and composition of the atom community respond to natural environmental factors in order to later understand induced change in the habitat. In all ecosystems, including aquatic ones, there are complex interaction networks that determine the characteristic of the ecosystem components. Generally, these interactions are represented in theory in a series of concepts that merit an analysis that integrates all of these into complex networks. For this approach, a structural equation model is a very useful tool that allows us to represent constructs using models that represent the interaction of the different variables. And the structural equation models is a multivariate statistical method that allows us evaluate of a network of relationships between manifest and latent variables. In these statistical techniques, pre-conceptualization that reflect research questions create the initial framework for the model development. In this slide, you can see what is the pre-conceptualization for the research. We have in the center the diatom community. We hypothesize the different variables that can influence the community of the diatom community. With this premise, we ask the following question. How the community composition of the atoms change in function of environmental variables? To ask this question, first, through structural equation models, determine the relation, the key environmental factors that influence the community of the atoms. And two, evaluate the performance of new environmental remote sensing information like vegetation index and textural metrics, topographic and bioclimatic information like environmental latent variables in the structural equation modeling. And three, evaluate the productivity through chlorophyll or periphyton, evaluate the physicochemical parameters, and evaluate the habitat variables of paramo streams. We study, the study area was the Cajas Massive because it's a very important area for around 1 million people that need this area for water supply. In this area, 16 microbasins were selected in Paramo zone of the Cajas Massive. I am lucky because Rolando explained what is the Paramo. 60 tributaries between 1 to 3 orders were selected. In each stream, 2 separate stations were selected at least 2 kilometers from each other. 32 sample stations in total we study. We did 4 samples campaigns, 2 in wet seasons and 2 in dry season. Related with the conceptualization of the models, we select different types of data sets. First, the biotics. Of course, we recover information about the atom community, macroinvertebrates, chlorophyll. For climates, we choose the bioclimatics variables from WorldClim, and we choose the season like a climatic variable. 3, for the habitat, we select the QBR and EHF that is for evaluation the fluvial habitat and riparian vegetation. Like habitat variable, we choose the vegetation indices NDVI and NWI derived from remote sensing. The hydrogeological morphological variables, we choose the flow and slope. For the physicochemical parameters, we measure in situ pH, dissolving oxygen, conductivity, temperature, We take water samples for measuring lab anions and cations. For the file sampling, first, in each tributary, a segment of approximately 50 meters in length were established, and two, we measured the parameters of physicochemical, in situ pH, temperature, conductivity, dissolved solids, dissolved oxygen, and three, hydrogeographical parameters like weight, depth, current, velocity, and flow were measured, and habitat evaluation index, fluvial habitat, and Cuvier, that is the riparian vegetation index. This was adapted for the paramo. For take the atoms, the samples of the atoms, we scraped 3 stones from the stream, 75 square centimeters in total at each station. For the identification, the cleaning were carried out by means of the oxidation of the hydrogen peroxide. Later, they were identified to genus and species taxonomic level, quantified by means of direct counting techniques in 24 slide plates. In each plate, we put an aliquota, that is a drop, in each plate and count directly with a microscope. We collect 20 macroinvertebrates by means of a kicking net for 3 minutes at each station, and were conserved in ethanol at 70% for their identification in laboratory. For the chlorophyll, again, we scrapped a stone, 25 centimeters squares, centimeters, and put these samples in a container with 100 milliliters of water. For filtering in lab, measure the chlorophyll through spectrophotometry techniques. This is the habitat variables. I explained the fluvial habitat index and riparian forest quality that was adapted for the paramo. We measure in situ, and the NDVI and NDWI we generate from Landsat image, Landsat 8, from the age the 2018 and 20 to 2020. We collect 12 images in total. And after that, we generate the vegetation indexes. We calculate the texture metrics, because the texture metrics is a good indicator for habitat heterogeneity. For the climate, I mentioned we choose the world climate. We collect the 19 bioclimatic variables and the seasons. And for the hydrogeomorphological variables, we measure the width, the depth, flow, and slope. And for the physicochemical parameters measured in situ, we measure the temperature, pH, conductivity, solid, dissolved solid, and dissolved oxygen. For the cations, we measure the potassium, sodium, calcium, magnesium. And for the anions, we measure the chlorides, nitrates, phosphates, sulfates, and fluorates. For the chlorophyll, we use 2 methods. The monochromatic method for only measure the chlorophyll A, and trichromatic method for measure A, B, and C chlorophyll. Of course, we have a lot of information, and for the PURTE model, we need to reduce the quantity, and we did a collinearity analysis We use the PLS regression because it's one of the most widely used analysis. The process first we apply a fine correlation that select the most correlated and discarding between variables of the same type. And after we apply the auto PLS generates an automatic selection of the variables. All this process we perform in our studio. This is the process. We take the variables and apply the fine correlation. And after the auto-PLS, and the auto-PLS select the most significant variable. I want to explain a little bit the vegetation index because it's new in this type of studies, because it's a good indicator for health of vegetation and for the habitat structure. We collect 12 images and we generate the indices and calculate the texture metrics. And for each of this layer generated, we take the information for each sample station. We generate for the point 1 pixel, and we generate a buffer in the stream of the 100 meters and 1,000 meters, and we extract the information of all of these layers generated previously, and we calculate the means, medians, standard deviation, and coefficients of variation. And we have a lot of information, and we need to apply against the fine correlation and auto-PLS for select the most significant. This is the results. The auto-PLS select for the climate. The most important variable was the season. For NDVI, we have 30 texture metrics, and for NDWI, we have 7 texture metrics, and for hydrogeological variable, the slope was the most significant. For the physico-chemical measure in situ, the pH was the most important, and for the cations was the sodium, for the anions, the nitrates, and for the chlorophyll are measured with the monochromatic method. This is the results. We count and identify around 380,000 cells, diatoms, from 43 genres, 127 species, and for the macroinvertebrate, we identify around 11,000 individuals from 62 genres. And this is the last results. The structural equation models identify the relations between the variables, and for the diatoms community, the season and the nitrate was the most important. Season like a climatic variable, and the nutrients, the nitrate was the most important, and have a direct influence in the diatom community. The NDVI influenced the nitrates, and slope influenced the nitrates. And it's an effect indirect from diatom community. And the diatom community influenced the macro richness, and the abundance is not directly influenced by the diatom community. And the diatom richness was the most related with these variables. We have a little bit of the problems with the abundance, because we count, in some case, we have some species with a little bit of quantity of the individuals, and other species we have thousands of individuals, and we have a lot of variation. And the richness explain better this model. We want to investigate a little bit more about the season and what happened with the atom community, and with this NMDS, we analyze the composition, the atom composition, and the dry scission was the most important and have more influence in the structure of the atom community. A preliminary consideration or preliminary results, we can say through a structural equation model, it was possible to determine the variables that most influence the structure of the atom community and the relationship between them. Nitrate was the most important chemical element. Seasonality changed community structure, so climate change could affect the bottom of the food chain. And the vegetation indices derived from remote sensing better explained the quality of the riparian vegetation of the streams. And the number of variables that could be considered for the future study was considerably reduced. That is very important because count the atoms is a very strong work. Thank you very much.
Thank you very much, Edwin. I think everyone is daring for coffee, so I would suggest that we reconvene at 11:20 so that we just have a 15-minute delay in the end, hopefully. So enjoy your coffee. Thanks, Edwin. Sì. Okay. We would like to reconvene, so maybe also the ones from outside can come in again. People are always late, right? After the coffee, it's always difficult to get the people in again.
The coffee here is very good.
Okay, while everyone is coming in and taking the seat, I'm announcing the next speaker. It's Francisco Prieto from INABIO. He's vice director there, and he will talk about the effects of climate change on biodiversity state of the art in Ecuador. So it would be great if you take your seats quickly so that Francisco can start. Okay, floor is yours.
Thank you. Si me pueden ayudar con la presentación para... Exacto, muchas gracias. Okay, hello, good morning to everybody. My name is Francisco Prieto. I'm the Deputy Technical Director of the National Institute of Biodiversity, INABIO. Before a complicated flight to get here, it's a huge pleasure to be part of this symposium. I will be very brief because, first of all, I'm not an expert in this issue. And second, just as National Institute of Biodiversity, we want to deliver three important messages about these status effects of the climate change of biodiversity. First of all, as INABIO, we are in the middle of the huge project to increase the knowledge of biodiversity in different levels: ecosystems, species, genetic resources, interactions. The knowledge is very poor yet, but we want to increase the knowledge, especially for policymakers and the society. For that reason, we want to publish this report. It's like a second edition because the first one published 23 years ago. So, as many of you know, there are a lot of reports, a lot of policy briefs, there are a lot of products from NGOs, initiatives, governments that establish the knowledge of the status of the biodiversity, the problems. And all of them has a particular topic, the 5 threats of the biodiversity. For example, land and sea use change, pollution, species overexploitation, like fisheries, climate change, and invasive species and disease. About climate change, as you know, the authority and information here at the global scale is the International Platform of Climate Change, the IPCC. And the IPCC published maybe days or few weeks ago the 6th report. So in this report, as a bad news, established adverse impacts for human-caused climate change will continue to intensify. Yeah, we all know about that. But interesting topic that the biodiversity is not confident. There are enough data to establish the real effect of biodiversity. But this report established that future climate change is projected to increase in the severity of impacts across natural and human systems and will increase regional difference. And as you know about geography, our country is in all scenarios. Our country is a mega diversity country, but is a country that be affected by the climate change. So, as the government, Ecuadorian government, the Ministry of the Environment, the National Secretary of Science and Technology, and the National Institute of Biodiversity established an agenda to establish priorities in research of biodiversity. In goal 2 is the study of functional diversity and the response of biodiversity to drivers of change. Remember, overexploitation, climate change, alien species. And so it's very important to promote that the academia, the research centers, and NGOs to increase the studies, the programs, the research in this topic. So the first message is, what is the state of art in terms of research? We established a basic methodology about search articles, books, policy briefs, thesis in different vias, and besides, there are 2 studies that help us very much. The first one is from Selene Baez and et al., Effects of Climate Change on Andean Biodiversity, a synthesis of studies published until 2015. This is focused in the Andean region, the tropical Andes from Venezuela to Argentina. So in this article published, their search, they found there are 65 published articles about this issue. And these articles focus especially in spatial distribution and biodiversity in different groups of biodiversity in the Andes. And the other article is published maybe last year or a couple of years ago, the priorities on action and research for the protection of biodiversity and ecosystem service in continental Ecuador. So one of the important things about this article is the region, the province that has more production, more knowledge production. So you can see on the south is Loja and Zamora, Pichincha and Napo is the most productive province in terms of production of knowledge. Until now, as a preliminary results, we found 307 articles aligned to the climate change and biodiversity. The important that the Andean region and the Galapagos Island is the most productive regions in terms of in research, in climate change, the effect on biodiversity, and there are increase of knowledge in these years. This last period, from 2015 until now, is the best period of production. So, important facts about current evidence. More extreme wet and hot conditions in Galapagos, change in regional terrestrial climate variables and sea surface temperatures. You know, especially the El Niño oscillation events is the most critical events of climate here in Ecuador, especially for penguins or marine iguanas. Anthropogenic carbon dioxide emissions and ocean acidification represent a risk to Ecuador's marine and coastal ecosystems and the service that provide. Right now, there are a problem with the fishery stock. For that reason, ocean acidification, pollution, there is a problem, and the fishery is important economic activity here in Ecuador. Species migrations, or population decline and thermophilization of plant communities. For example, population of frogs associated with a fungus start to decline, especially for the foothills and Andean regions. Andean forests, as another ecosystems species that lack the ability to quickly and coexistently respond to climate change. The climate change is increased and fast rate, but the capacity of adaptability of these species is not as well like that problem. The effects of climate in the Amazon reflect a migration to higher levels of disease vector as arbovirus, malaria, leishmaniasis, or Chagas. It's more common to find this disease in higher altitudes here in Ecuador. And Galapagos penguins, marine iguanas, marine turtles, coral reefs, primate, frog, lizard, Toquilla palms. Toquilla palm is the species that produce the fever to make the Panama hat. Is one conserved species right now. Might be the most severely grouped affected by the global climate change here in Ecuador. But another aspect is a good news. In this analysis, established that a good strategy is make networks. Network like the EBIOLAC is a partnership between different universities in the coastal region to start monitoring the ocean acidification. Or the Red Gloria is a network in the tropical Andes that established pilot studies to monitor the climate change effects of the plants. Or the science panel for the Amazon. This panel is more aligned to establish a bond to policymakers, to produce information, produce data to policymakers in the Amazon region. But the most effective, is very good news for here, is the cooperation with Germany, yeah? Because it's the most successful long-term project or program here in Ecuador and the most effective in all Latin America. It starts with the Team EMF in the final of the last century and increased to the respect, and now has like a twin, like a resemble. Us, with Ministry of Environment and the National Secretary of Science and Technology, established a pilot called COSIVIO. Was a program to promote, to establish a call to get funds between German's university with Ecuadorian's university. This program finished the first stage, and we hope to obtain the funds to establish the second phase and make the second call. And finally, and for that reason is very important my presence here. All knowledge is useful if the data, the information is the delivery to policymakers to establish a monitoring strategy to conservation biodiversity. So, using species distribution models for the design conservation strategy of biodiversity under climate change. In 2015, we established what is the most important areas. So we use the species, the information about the species, and modeling the estimate distribution, and know and determine how the national protected system of Ecuador is working to protect that biodiversity, especially threatened species, endemic species, and other important species for the analysis. So in that, this analysis was and is very useful to increase or create new protected areas right now here in Ecuador. So the government, the Ecuadorian government, right now has an important tool to determine where is the next protected areas, where we'll need to create these areas. So the National Institute of Biodiversity create a database. The government established that INABIO must to create a mechanism, a way to put the information, to put the data. Right now, Naturare becomes the tool to integrate different platforms of data like BioWiki, iNaturalist, Ecuador, Alien Species Exotic Database, and the collection database. So it's very important for us to collect the data and produce information for our main partner, that is Ministry of Environment. So it's very important. In the academic level, yeah, it's very important to produce papers, but it's more effective if that information also is used for this kind of initiatives. So key message, many impacts of global climate change, including ocean acidification, rising temperature, changing rainfall patterns, and ocean currents, extreme weather events affect biodiversity. All we know that. And putting pressure of species already threatened by other human activities. A comprehensive network of climate and biodiversity monitoring observatories and a system for sharing comparable data is needed to diagnose ongoing change, like Amazonas region, because in the current year, we are not enough information about climate in the Amazon. Just INAMI, the National Institute of Meteorology, just have maybe 3 meteorological stations in overall region. More integrated studies on biodiversity loss and climate change, for example, on wetlands and marine ecosystems are needed, and ecosystem and species resilience to increase temperatures and reduce water supplies. National strategies as the National System of Protected Area plus habitat connectivity to other areas like a subnational conservation system, socio-bosco program, corridor, etc., to be a species movement, keep protecting our species from climate change. So maybe it's the last one. Thank you.
Yeah, thank you very much, Francisco, for his nice statements and what we need and what we have learned so far. Is there any urgent question at the moment? Yes.
Thanks, Pancho. I was just wondering, do you have any idea how this information gathering has been effective for the political decisions? I know that gathering this all information in one platform, the idea is to protect more areas and also the biodiversity, but so far, how is it's been effective, like in general aspect for biodiversity here?
Tricky question, because the first step is establish the protected area or increase protected area beyond that ecosystem or habitat that is very important for the species. But right now, the problem with the protected areas is effective management. So maybe the next step is establish monitoring programs to evaluate these trends of biodiversity, the problems of biodiversity in this area. So this is very important. Maybe that step is huge, is very important, is very problematic right now because there are not consistent, there are not harmony between the Ministry of Environment with the academy. There are a lot of problems to get permissions, to get, I don't know, the permission to do the research. So we are in the middle of that process.
Thanks.
Okay, thanks very much. I think we move on to the next speaker. Oh no, one quick question, but then we continue.
Good afternoon. Only one question. Where being installation meteorology station and what they produce in the change clean?
Sorry, I can't get the question. But could be in Spanish, sorry.
Meteorology station.
Yeah, from INAMI.
Yeah.
Yeah, INAMI is the authority to produce data in meteorological aspect. But INAMI has maybe in the late 60s or 70s, established as a priority the coastal region. Yeah, the region that produce bananas, coffee, cocoa, sugarcane. For that reason, it was very important to establish this station to get data. So the Amazon in that period is not important in terms of produce, because there are just oil and there's no need climate information. So there are a lot of problems from 80s to that institute to establish new meteorological instruments. So, for example, the most comprehensive data about the Amazon has the German cooperation from the respect from the Zamora Basin. So it's very important to increase these stations in overall Amazonian region.
Okay, very good.
Okay, thanks very much, Francisco. We move on. Our next speaker is David Donoso, who has been here some time ago at UTPL, which we just saw on the slides, but is now in Quito at the EPN, and he's part of the central module of reassembly and will introduce us to the other research unit funded by DFG in the north of Ecuador in the province of Esmeraldas in the Chocó. So the floor is yours, David.
No, aquí estoy. Hola. Good morning, everyone. I don't know if I'm going to speak in Spanish or in English, so I apologize in advance. Thank you, Nina, for inviting me to speak about this reassembly project, which is more of a German project, and so it's very nice that an Ecuadorian get to talk to Germans about German projects. But nonetheless, it's a pleasure to talk about this project that we've been working for at least 5 years with Nico Blutgen so far. We are in the second year of this project out of the 4 years that the project runs. We have already a few results, but the idea was to introduce this project here in the south to our Loja friends and also German friends. So this is more of an introduction to the project rather than to show our results or what we have accomplished so far. Before I start, I want to say that it's a pleasure being here at UTPL and see all of my friends that about a decade ago I used to have here, so I miss you, and thank you for receiving me so well this last day. So the other thing that I'm going to do is my presentation is in Spanish because I want to make sure that all of you who don't speak English can follow. Mi presentación va a ser en español, although I'm going to speak in English, so la mayor cantidad de gente puede entender de lo que voy a hablar. The forests are disappearing. We all know that. We study that. So it's not something new. What is interesting, I don't know if... What is interesting is that most of the forms that the forests are being disappeared here in South America is through agriculture and pasture. So this is unique to South America. Forests are being cut all over the world, but here in South America, most of the disappearance is because plantations and cattle. We in South America also have not so much of the remaining area as native forest, continuous forest, but we are disappearing it maybe the most quickly around the planet. So most of South America now looks like this, especially here in Ecuador. We have a lot of cows. And so what we wonder in this project is how the forest goes from here to a primary forest. We are interested in the recovery of the forest. We know that this recovery is very variable and is influenced by the amount of forest nearby, is by soil nutrients. We know a lot of factors are affecting the recovery speeds of these forests. But we also know that the different legacies of different human use by these forests, for example, pastures and cacao plantations, do have an imprint in the way the forests are recovering. And in the core of the reassembly project, we're interested in give more knowledge about this process of recovery, forest recovery, using pastures and cacao plantations as sort of baselines to understand this recovery. I'm also going to give you like the three main concepts that we use in reassembly. We talk about these concepts every time we talk about the project. So we define disturbance as any activity, human activity or natural activity that remove biomass from the system. And we try to measure the recovery of the forest while we understand these two measurements of the disturbance process, which is resistance, which is the amount of any given property that remains in the system after the disturbance, and resilience, which is the speed that it takes for this property within the ecosystem to go back to normal levels. So a little bit more of numbers. This is a recent study we just published with Philip Honley. I don't know if any of you know him, a nice grad student, now postdoc in Czech Republic. So, for example, we found that around 61% of the ants species in the forest remain in the disturbed forest after the disturbance. And it took about 29.8 years for the species richness of these pastures and cacao plantations to go back to normal levels. So this is the concepts that we use. So just to be clear, this is what we are interested in, to understand the recovery processes across cacao and pastures. We study different aspects of this recovery. The first one, you may know, species richness and diversities, but we're also measuring traits. And so we try to understand how the traits are recovering. And finally, we're also interested in how the whole process community recovers in the system. And so this is reassembly. This is everybody which is involved in the project. You may know already some usual names here, Eike and Nina, that are part of the research unit here in the south, are also participating in the north. And I actually couldn't put some pictures and couldn't put all of the other people that are involved in the system, but here from UTPL we have Diego Marin. Some of you may know him, working with saproxylic insects, and other you will know. So this is how we look. This is us in the Bavarian forest. Jörg Müller received us last year for the first annual meeting of the reassembly project. And this is how we look a little bit more dirty in the field, where this was our kickoff meeting last year also as well. So reassembly is a series of projects, sub-projects. Give me 1 sec, please. There are 7 sub-projects, all of them dealing with different aspects of the forest. For example, we have a sub-project interested in predation of leader invertebrate by frogs, deadwood decomposition, dung beetle removals and seed dispersals, seedling recruitment of the plants across this gradient, seed dispersals by birds, bats, and rodents, and pollination of the plants by bees and moths. We have a unifying sub-project, which is the theory part of the project, And there is it's not a sub-project, but it's the central module that is, I'm going to talk a little bit more about the central module after that. To talk about all of those projects will take me a few more hours, so I'm just going to focus on 2 of those sub-projects just to give you a better idea of what we are more specifically doing and how these projects relate to each other. So on SP2, Michael Hitoff and Mo, also with a colleague, Ralph Saporito from the United States, and me, we are interested in understanding how the recovery gradient affects the predation of leader invertebrates by frogs. We know that frogs do recover fast. The frog communities do recover fast. They take between 20 and 30 years, but we don't know what are the processes that are mediating this fast recovery. In South America, we also have the poison frogs, the dendrobatid frogs. So this is a specialized group of frogs that have a very specific diet that they need to eat in order to get the alkaloids for their skins. So we are just doing that. So we are measuring frog diets and dendrobatid frog diets in these grasslands, and what we are interested is in testing for how these networks, predator-prey networks, changes between dendrobatid frogs and non-alkaloid frogs. And we are interested to know the role of the alkaloids in mediating the recovery process in this landscape. So we think that the complexity of the network will increase from a degraded pasture or cacao plantations to the primary forest. Alkaloids networks will be the most affected by the disturbance, and non-alkaloid networks, those networks composed by frogs that don't need alkaloids in their skins, will be the ones that will recover fast. So again, we're interested in how all of these networks and different aspects of the networks and different aspects of the biology of the species, in this case between frogs and their diets, are recovering across the gradient. To show you a little bit how these sub-projects relates to other sub-projects, because this is a highly interconnected, it's very interesting. I like this reassembly because the way everybody is interacting with each other. So we are gonna give our primary network data to SP1, which is the theoretical sub-project, and we're gonna give arthropod data and decomposition rates to the central module and sub-project 6 and sub-project 7. And we're going to give also environmental data to the central module. And we are also catching staphylinids in the diets for SP6. Now I'm going to talk to you a little bit more about SP7, the sub-project 7. This is the second one that I'm going to talk to you about. I'm not going to talk about all of the others. And this is the saproxylic insects and with the composition sub-project that is being done by Heike and Jörg Müller. So we know that the insects affect decomposition rates of the woods across the planet. We know that these effects of the insects can be positive or negative. For example, they can be positive and increase the decomposition rates in warmer and more wet places of the planet, but they can actually reduce decomposition rates in the colder and driest sites. So we know that insects do have an effect on decomposition rates. So what we're interested in is to see how these interactions between the woods, the saproxylic insects, and the fungi shapes decomposition rates across the perturbation gradient. In these two projects, we're also doing two other additionally experiments. In the first one, we are putting different kinds of woods across the gradient to see the interactions between different saproxylic species. For example, we expect that the ants will deter the functioning of the termites, and we expect that without the ants, the termites will increase the speed of the composition of the wood across the gradients. So this is another important aspect of reassembly, that we are measuring different ecosystem processes across this recovery gradient. Just to give you an idea of how this subproject specifically interacts with other subprojects, we are measuring or sampling ants and mites for subproject 2. We're going to have measures of saproxylic insects as pollinators for SP3. I don't know how realistic is that, Nina. But we're also giving rates of the decomposition process again for SP6. And again, we are giving all of our data to XP1, which they will use to give more theoretical background to the recovery process. So just to give you a little bit more information on the organization of the research unit, these are all PhD students. We have 3 Ecuadorian students in the mix, which I think is nice. It was hard to recruit Ecuadorian students for this project, but we have 3. And it has also supported 2 other grad students, Phil Homley and Gemma from Mexico, in the pre-project time. Just to give you an idea of how our project looks like on site. This is our series of plots. So we have different plots in different stages in this recovery gradient, and they are all within this forest perturbation mix in the northwest of Ecuador, in Esmeraldas. That, by the way, is the province where I was born. It's very hard. I don't know if you can have an idea with this image how hard it is to go from one plot to the other. But we have 62 plots across the gradient. There is also the central module. The central module component of the project is very involved in like standardizing all of the DNA barcoding. We are barcoding a lot of species in this project. And also we have to work closely with Martin Schaffer. I don't know if you know him, but he's the director of Hokotoco. That is also included in the project. And we also were very involved in plot selection, which was a complete year, just 1 year choosing plots around the area. And other smaller things. I think it's important to talk and to remind that we are working with 3 contratos marcos that are dealing with different aspects. UTPL here in Loja with Diego Marin is helping us with insects, for example, so all of the videos are coming here to Loja, even though they are very far away from our universities there in Quito. The project is increasing, bringing the attentions of other researchers in Ecuador. For example, these two colleagues of mine, Paul and Ruben, they are doing all of the alkaloids. I don't know how to say that, but they are extracting the alkaloids for us in Polytechnica. We do have workshops, just as maybe this one here, and annual meetings. We already have one annual meeting last year, and we are already planning the annual meeting in this year. And if you want to know more about our reassembly, we do have a newsletter that we actually copy the idea from you. We were looking for how to expand the outreach of our project, so we come up with this newsletter. And we do have a web page that you can check if you want to know a little bit more about the different things that we're doing, and all of the news are also there. Thank you very much.
Yeah, thanks very much, David, for this introduction. We have time for one quick question, but at the moment I don't see any, so I think then we will continue, and maybe the questions come over lunch or in the next coffee break. And our next speaker is Bruno Palladines, and he will talk about the conservation of biodiversity in indigenous territories of the Ecuadorian Amazon with mitigation effects on climate change. Thank you very much. And Bruno is an ecologist and in charge of these projects. So the floor is yours.
Okay. Good morning, and thank you very much for allowing me to share this presentation with you. Welcome to all the Ecuadorian and German researchers and all the visitors. Thank you. Okay, I want to briefly to introduce you to one of the scaling projects that NCI in the last 4 years approximately has been developing in the Amazonian region. NCI, as you know, is working already 26 years already together with the German program, and in parallel, of course, we have been doing conservation and sustainable development, initially with I would say, focalized probably space in southern Ecuador, but in the last years we have and are convinced that we need to enlarge our vision because as we say, we are losing the battle with again unsustainable issues, and we need to do more work. The name of this one of these programs is the Amazonian platform, and I would to invite you to think a bit about what is happening now in countries like Ecuador at the subnational level. Okay, is to share some considerations of departure towards the declaration on provincial reserves and why this is important in our countries. But first of all, I would like to say that we are very proud having Edward O. Wilson as part of our board of directors, as part of our organization till 21 when he died, as we all know. And this is one of his greatest thoughts that inspire us as an institution, and I would say that most of you probably read O. Wilson and found this amazing and beautiful thought. And I would say that as we have seen, and we, with all these results, that worry a lot to us, all the research, all the findings you have, most of the effects and consequences are there. We need to think more about strategies, about models of governance to know how to deal and how to do more work and how to conserve all those forests that you are researching and we all need as a planet. And Wilson said that look closely at nature is what we do every day as an institution, is what you do every day as researchers. And who we are, yes, to destroy it and even diminish that biodiversity. The work, the part of the work we do as NCI is exactly to help the national government, the local governments, in order to advance a bit more and conserve all that biodiversity. But maybe for some of you, probably the youngest, who is NCI? I mean, which is our organization, what we do. And Nature and Culture International is dedicated to conserving biological diverse landscapes in Latin America. It's our main view, as our main mission, is what we have been doing the last 25 years, in concert with local people. That's crucial for us. Especially supporting the creation of protected areas at the subnational area. And this is a good example of why that might show you and all the institutions why we work with subnational areas that we will discuss a bit later. Ensure management at the subnational and sustainable financing for those areas. Once we create those areas, what happens later? We know management is crucial. If we don't have enough money to do that, the creation is not enough. Create connectivity corridors of protected land. As I said, we started localized in Loja, but now have a greater vision. We are working in Ecuador, we are working in the neighbor countries, and we understood that we need to work in the connectivity of all those ecosystems. And of course, empower indigenous communities. That is probably one of the most difficult things to do, and I would say that there are reasons that explain this. What is the Amazon platform? That is mainly a subnational strategy of the 6 provinces of Ecuador, Amazon provinces. Here we see in a first stage, 3 of them, Pastaza, Morona, Santiago, and Zamora, supported by the bilateral now and also private cooperation. That is a good thing. And NCI has been the last years the technical and financial partner of these provinces. What we see here is, and you are familiar with these, are the watersheds of the Amazon. And Ecuador is a small country. We know we have only 2% of the entire Amazon. We contribute with 2%. But as you know, the Napo and Marañón and a bit of the Putumayo watersheds are in our country, are the sources of the Amazon River. And this is crucial because these are the headwaters of the Amazon. As we know, the biodiversity that is located here is bigger than in all of the rest of the Amazon basin. So what we do in this piece of land of the Amazon basin is crucial for the conservation and a good stage of the functionality of the entire Amazon basin. And Ecuador has approximately 10% of the 3 watersheds, the Putumayo, the Napo, and the Marañón basins. What we what you see here is a map of Ecuador of the east part. The dark green is the national system of protected areas that protects approximately 3.6 million hectares of forests, paramos, and so on. But the two light greens is the forest that is outside the national system of protected areas. More than 4 million hectares of forests that are not part of the national system, are not part of the national strategy of conservation. Of course, there are things that have been done, like the bosques protectores, or the last years we have all this movement based on the new goals of the 30-30 conservation at the global scale, as the OMEX, that are other measures for conservation. But in general, if we see and evaluate what has happened outside the national system of protected areas, and this is not so different in the neighbor countries, I can say that we have not done so much, probably very little. And what we want exactly with this strategy is to look more closely and work together with the counties, and especially the provinces, and the owners of these forests that are the indigenous nationalities. Then the strategy mainly is for the 6 provinces to work together with the national government, with the indigenous nationalities, in order to protect the headwaters of the Amazon basin at this subnational level. And we have been working for the last almost 12 years already in this idea. We started in Pastaza, that is the Pastaza, Morona, and Zamora Chinchipe. And as part of the work, as you maybe know, we supported the creation of provincial reserves. And it's amazing that we have already created, under a concert, under an agreement with the national, the provincial governments and the 7 nationalities, in area that is already close to 4.5 million hectares of sustainable, of conservation and sustainable use areas, as is the official name recognized by the government, the ACUS. One of the things that I want to forgot the word in English, to express here very strongly is that what is needed for this is to come to agreements. I think that part of the work, part of the situation in reality is that we have not worked together until now in terms of the national government, the subnational governments, and the indigenous nationalities especially. Here you can see a reality that this is crucial in the strategy. In Pastaza, almost 94% of the territory is in hands of the 7 indigenous nationalities. In Morona, 66, and in Zamora, 33. The goal of this strategy is to advance in the strategies for climate change and and biological and cultural diversity in order to work together at a subnational but also multi-level approach. As we have found that and our findings can, and we are systematizing already this experience, but it's clear that as NGOs, as a subnational government, as a national government, and cooperation, we have not been working together to look at the forests that are outside the national system of protected areas. These are just some maps to show you the reality of what is happening in that territory. We have over 11 million of acres. That are approximately 4.5 million in the case of these 3 provinces, but the entire territory is, as I said, 6 million hectares of forest, with more than 90%, 90% of forests that is still there. This is for the 3 provinces. 76% of this territory is in hand of the indigenous nationalities. Of course, as I said at the beginning, this is probably one of the most biodiverse areas in the entire Amazon. Share, of course, with Peru, with Colombia in these headwaters. No? We have 32 ecosystems, and the province of Morona Santiago is probably the richest in terms of the diversity of ecosystems. Of course, the amounts of carbon stocked in these forests are the biggest for Ecuador, no doubt of that. And the good thing is that we already started. In the last 2 years, we have worked together with the 3 provinces, and they started the work with the nationalities in order to define what are the goals, what is the vision for the how we, as we call the Plataforma Amazónica, and this is more or less what we are doing now and what are the next steps as well, because this is a vision for the next 10 years. We are working on the RED implementation plans. We are working in the zoning plans for indigenous territories. That is, of course, a strategy that is part of the national vision, and also the thing that are doing other NGOs and other institutions, Los Planes de Vida, that is the name in Spanish. But the idea is to put all these plans, all this vision inside the management of the protected subnational areas. We are working interprovincial projects. We are now developing one of the most important things from our point of view, that is a finance mechanism in order to, as I say, to create the sustainability and the financial clarity that we need in order to manage this forest that is the biggest connected forest outside, I said, the national system of protected areas. We are working at the international level as well as I said, and the 3 provinces are now part of the Governor's Climate and Forest Task Force International platform that allows the provinces to have an international voice and to have also the connection with the international and subnational goals and policies and possibilities to raise money in order to work these plans and this vision. We are working on a coordination mechanism, because this is not easy, of course. We are working with some NGOs already and with the GCF in a baseline indicators and monitoring platforms. Here is where we need still to work and connect with, of course, the national policy, with the INABIO or with the work that other NGOs are doing, the monitoring of carbon that international institutions are doing. And this is the next step at what we need to develop, and to have a joint communication strategy. That's also crucial. And why we need to work at the subnational level. Very briefly, as we saw, these natural ecosystems and biodiversity are in a good stage. We need to work and to do something there. And unfortunately, we can say that is still unprotected. So what we do there in terms of climate change and conservation. There are similar provincial aspirations in terms of a community or a population that is not so big yet, and the development stage is more or less similar. this is an opportunity to work multilateral strategies for conservation that need us as NGOs, as universities, to think about creative ways to do conservation that goes beyond the conventional approaches. Of course, there is a closest relation with the indigenous population, and there are financing opportunities because this is a thing that, fortunately, but not necessary in the necessary or with the necessary speed, but many international cooperation is already understanding. But of course, this is not easy because we have a historical context from where we need to understand, and that is for us very, very important. For example, as I said, there was always a divorce, I would say, between the work of the central government, the subnational governments, NGOs, indigenous people working together. I would say that we never work together. That is a pity that has or is part of this problem. We have had imposition of conventional conservation strategies, paternalistic, unfortunately, strategies and ways of doing work that doesn't allow the construction of local capacities that are crucial. For example, we have found that there has been an overloading and misguided strategy on administration issues. We have put the responsibility of managing enormous amounts of people on hands of indigenous population. That is not easy. They have not had enough knowledge, capacity to do that, and that is a problem. A very serious problem in some ways. Yeah, and we have not have enough attention to the development of the region. There has been also racism. That is something that should be said. Ecuador, we have that problem also between our people. And of course, this has created a lack of confidence from the side of the indigenous people towards the work of NGOs or the state or the international cooperation, and how we do and how we overcome this problem. That is part of the strategy we want to develop together. And just a few examples against all this reality, what we do and how we are approaching, how we are doing the thing. As I said in the NCI subnational Amazon strategy, provincial governments, indigenous people, and the cooperation need or should work together. The action plans of the conservation areas are based on the indigenous zoning and cosmovision of these territories. The map there shows in dark green the area of the Quichua people in Pastaza. And here, what you see are the different, this is the zoning the Quichua people did in this work that is mostly the way how we will try to build with them and with other NGOs the management plan for this entire area. That is a challenge. We know only Pastaza has 2.2 million hectares. But the opportunity is there because this space needs or should be incorporated in the development process of the province, in the development imaginary of the authorities, of the institutional, public and private institutions. So the opportunity is there. But also, this map only shows one nationality. We are doing the same with other NGOs, with other partners, in order to have all this zoning process based on the planes de vida that have been developed in the last years, in order to have this vision, this indigenous vision inside the management proposal for these areas. Very short, I will not read this, but it's just to show you the strategic thinking we have put on this. We started, this is for Pastaza, and we started in 2011 when we helped the provincial government to put the vision of conservation and sustainable development into the plan de ordenamiento territorial, the policies, the environmental policies, the creation of the provincial area in 2017, incorporation in the GCF task force, the construction of the RED implementation plan. So this is not a thing that might be achieved with short projects. Needs to be a work in the long term. This is just, for the last two slides, just to say that this is the case, for example, for the very rich process we have had in Morona, Santiago for the creation of the Tarimia Pujutai Nunca. This is the name that the Shuar people gave to the provincial area that means the land of our ancestors. So, and the name is the territory of use under our vision and cosmovision. This is just to show the area, the territory that they own. This is the area. I know I'm late already. And this is just the strategy. As well, we have had a very interesting process of the prior and informed consultancy with the Shuar and Achuar people based on these agreements that, as I said, are critical for conservation. If we think that we can come along and do our work separately from an agreement, from a consensus of what the vision of conservation is, we believe it will not work again. Yeah, and just two pictures to show you what has been the pre-consultancy work, because this was approved in the provincial Cámara or Council. And recently, two months ago, we are proud to say that we created in Morona, Santiago, the second largest provincial reserve in Ecuador. And as the map in the beginning, 4 million already hectares of provincial reserves that are part of this Amazonian platform. Yeah, thank you. Thank you very much.
Yeah, Bruno, thank you very much for sharing these very important insights on community conservation and maybe other ways to go in the future that you took already some years ago. That's great. I think due to the time constraints, we will continue now and postpone all questions on experiences in the Amazon to the lunch break and the coffee breaks and maybe the poster sessions later on. And the final talk before the lunch break will be given by Jörg Bendix, who will talk about the Darwin project, and it will be on clouds and rainfall on the Galapagos Islands. The floor is yours.
Okay, thank you very much, Nina, for this introduction. Yeah, I can also take this one. Okay. Yeah, that works. So I would like to briefly talk about a startup project which came out of our community. So that rises light for some years. And you see the project is named Darwin. You know him. That is very biological, but the project isn't. So you see that the acronym means Dynamic of Precipitation and Transition, the water source of the Galapagos Archipelago under climate change. And you see that is a German Ecuadorian cooperation project funded as a bundle by DFG. University of Marburg has teamed up with the Technical University of Berlin, the modeling group of Dieter Scherer, and in Ecuador we have the group of Rolando from Cuenca, University of Cuenca, and the group of Daniela from University del Azuay. And of course this project works closely together with the Charles Darwin Foundation and the National Park of Galapagos. So the question is, and Francisco already talked about Galapagos, that there is a lot of research on biodiversity, biology. When we started this, we thought, we asked ourselves, is it really necessary to do something at Galapagos? Everything should be studied. But then we saw that the climatological studies are still not that established like in biodiversity. And that leads, the reason is, of course, because we don't have a very dense operational network. You see here one of the rare stations from Inami in Puerto Ayora. And that is a very old station, which is also operated by Charles Darwin Foundation. So why cloud and rain in our title? Yeah, and also that is already stressed in Francisco's talk. So we are on a volcanic archipelago. There is almost no groundwater table. But there is, of course, fresh water needed for ecosystem, people, and also for the tourists. And so that comes from the atmosphere, from cloud combing and rainfall. And that's why the question is, of course, what happens in climate change? But before I go a little bit more into detail, just some slides from this Puerto Ayora station, just to bring you on the scope. So we have 2 seasons which are described there, a so-called hot season and a cool season. And the hot season is, of course, warm, culminating in March. And the cool season is here in August and September. And you see that the warm season is wetter and the cool season is drier in the precipitation. So that's what we already know. That's not that different from that what we have in the dry forest. Climate change is also talked about. That is a little bit complicated, as always, in Ecuador, because we see that is the temperature signal in Puerto Ayora. There is a weak trend, so global warming is there, especially if you compare it with the sea surface temperature. But there is a lot of variation, and these variations, particularly these high peaks, as already said, are from the ENSO phenomenon, from El Nino, Southern Oscillation. And if you are going to rainfall, you almost see no trend in rainfall so far over the last decades, but you see also these huge peaks, which are also related to the strong ENSO effect. So that is really no. But there is a high uncertainty, and that is very important for biology if we are going into space. There are a few points only on the island, and we don't know about the spatio-temporal dynamics of clouds and rainfall really in space. And if we don't know it, then it's very hard to assess what happens when climate change comes. And there are some interesting hypotheses in the literature which say that the most water is not coming from El Nino convective rainfall, but from the Pacific stratus clouds, by combing out the clouds or light drizzle. That is the garua, they call it. And that said, that this stratiform rainfall in the highlands is most important for the water supply, but it's not justified so far. And the second hypothesis is that if we have warming, then the Pacific stratus will weaken and the stratiform rainfall will decrease. And our question is, okay, El Nino is warmer, we saw that. Maybe that is a surrogate for what is going on in the future. But we all are aware, of course, that the situation will be very complex in space because we have a lot of confounding factors like ocean currents, topography, wind exposure, and so on and so on. So that is what we would like to understand in Galapagos. That is the main goal, to really understand the rainfall processes and its cofactors in space and time. So that's what Darwin is about. And to do that, we are mainly investigating a transect of the 3 big populated islands from west to east, Isabella, Santa Cruz, and San Cristobal. And there are already some of these cofactors. Ocean currents are very important. In the eastern part, that is the influence of the Humboldt current, which is seasonally changing with the warm equatorial current. But on the western part, we have upwelling, very specific, that is a so-called undercurrent. That is completely different in this transect, which with regard of the ocean forcing. And then we have, of course, altitude. That is a problem. We have Lafley effects because we have mostly winds from southerly direction. We will see it why, because they came from the South Pacific anticyclone. And what we also see is that, that is already known, of course, and well described, that we have a stratification also in vegetation, a dry base zone, then we have this Garua zone with Miconia forest and so on. And then in the highest islands, we stick into the trade inversion, and that's getting drier again. And this is, of course, where the water should come from. Independent from that, we still have these convective clouds. And so to come to our goal, we decided to employ point data, but also aerial data. And you see that are 3 work packages. So we have installed a transect of automatic weather stations from west to east to cover this gradient in ocean currents, but also from Lough to Lee, so to cover the exposition to the main airstreams. And so then we would also like to use the new GOES data, 2-kilometer resolution for a new rainfall retrieval. And finally, we also would like to employ downscaling of WOF also to 2-kilometer resolution that we can go back in the past. And the reason for that is, of course, is we need the data to understand what is going on and also to validate the remote sensing precipitation retrievals and also the atmospheric modeling. Here we would like to use machine learning, of course, to train the cloudy areas in rainfalls map and discriminate between convective Garua and occult precipitation. Occult precipitation is complicated, I already can say. And so then we will understand the mechanistic processes behind by using the atmospheric downscaling modeling. And at the end, of course, we would like to have the complete information in space and time on the atmospheric water services for the archipelago, which can be then used, of course, for applications and preparation or adaptation for climate change. So I just will give you a very brief snapshot what we have done. We started in last April, and first was, of course, to install the network of this 11 automatic weather station. We did it successfully. We have one so-called super site here at Cerro Croca in Santa Cruz in the Garua zone, where we have, for instance, 6 different rainfall observation technology, because we have this strong rainfall and we have this light rainfall, and that is very hard to retrieve it from models and also from satellite data, and it's even hard to retrieve it from ground-based observations. And that is why we have all these, the radar, here a small radar, here a pressure sensor, here the classical gauge, a fog water collector, a vertical pointing rain radar, and we also have a visible optical device which is not here on this slide. So and if you are looking into the first year, you see, of course, data gaps are always there. You see hot-cool season is confirmed, but we already see, if we are only looking in the gauge, in the radar, so then we see that, of course, it's wetter in the warm season and drier in the cool season. That is contradictory to the hypothesis, but it's only falling precipitation. It's not combing out the clouds, so that is a difference. And we see that there must be a lot of low clouds because relative humidity is always 100%. So there is a very low saturation deficit. And as I already told, we have very high wind speeds here because we have almost no roughness in this area, which means that cloud combing could be very, very effective, and the wind direction mostly southerly from the trades. I already talked about that. So what we did, we started with the clouds, with the MODIS data set, 20 years, 2 different time sets where we can discriminate for the grid cells if the grid set is cloudy or not cloudy, and can then produce over this 22 years frequency maps, and they are very interesting. I cannot go into much detail, but what you see here is the hot season, the cool season, the bluer or blacker, the more clouds, and you already can see here so the hot season you have less clouds, and in the cool season you have more clouds over the ocean. But you see, if you are going onto the islands, then you see very different patterns. There is a huge pattern between Lough and Lee effects in the dry season, but not in the wet season. So that is very interesting. And I just show you some details we found and which have to be analyzed. So lower cloud frequencies in the western part, since in the eastern part, here is the cold undercurrent, here is maybe the warm current from the equator. So what we see is this strong Lough-Lee effect. On the windward side, we have a lot of clouds. On the drier side, we have less clouds. And then, of course, we expect less precipitation. So the high volcanoes are very interesting because you see that they have very low cloud frequencies. That's because they are already in the trade inversion, but which means that most of the clouds are lower, so lower than 1,000 meters. That is all these Pacific low stratus, which is well known. And you see that you have lower cloud frequencies around the coastlines. That's why it's dry there, so that confirms what we already know. And that is very interesting. If you are looking here, there are all plumes of high cloud frequencies. That is a typical dynamic effect if you have stable stratifications, and so the islands cannot overflow, so we have a surround flow and we have a confluence behind the islands, and then you get more clouds. That's very interesting for climatologists, sorry. So we see that the dynamics is very complex at different scales here, and that makes it, of course, very complicated also to analyze climate change. ENSO, just two fast slides, which we did. We analyzed here the ENSO 2015 against the entire period, and what you see is that if it's blue, then there is more cloudiness, and you see in this leeward side, in this undercurrent, there is more clouds, and it's mostly more convective clouds, and also the cold water, the undercurrent is a little bit weakened. So that is the reason what you see. But if you are going in the eastern part, you see there is less clouds, and that also holds for these easternmost islands. And there the hypothesis could come into play. Maybe there is low stratus, which means at the end lower water supply. But it differs, as you can see, along this gradient. So La Nina conditions is exactly contrary true, because then we have very cold conditions, and you see that almost these areas in the lee and where the undercurrent are suffering from very, very low cloud. It will become very dry there. So we have also finalized the model. Now the model parameterization is ready, so we find analysis is calculating back to 1981 at the moment in the Berlin Institute. I just wanted to show you, Ben did also some interesting experiments where he compared El Nino, so the warm season, with the cold in 2016, and you see similar pattern in the model, so the model performs quite well. That's what we also see in the observational data. And the last slide, that is very interesting, because that is now the comparison of the model, of the downscaled model for the Cerro Crocker and precipitation. Here's the model, here's the radar sensor, and here's the tipping bucket. And you see, even in the measurement data, so there is a huge difference. We have some explanations, but that is very interesting to see that even if you set up some measurement equipment, you cannot be sure that they all give you the same data. And you see also that even if this seems to overestimate everything, so that the correlation and the hit rate, so it rains in the model when it rains on the gauge, looks very good. Yeah, so that's all what I wanted to show you. Just a brief run through the project and the first results we had. We saw already in the first data some very consistent processes observed over the three methods we had, but we have already seen that there is a very complex situation, that we strongly have to analyze these co-founding factors, where we are and when we are. Yeah, of course, ENSO has major influences on cloud and precipitation changes. Not really clear what happens with the Garua, so that seems to be different in the eastern part and in the western part. And but we can say if El Nino increases, we have more convective clouds and rain. As I said, Garua is not yet clear. So, and for that, I'm ready. Thank you very much for your...
Yeah. Thank you very much for sharing the insights on the new projects on Galapagos. We are a bit late in the time schedule, but now you have 60 minutes for your lunchtime, and most of you are familiar, I guess, that the cafeteria is just around the corner and you can get your lunch there, and we would be pleased if you are back here in 60 minutes, so at a quarter to 2, right? No, yeah, a quarter to 2. That would be great. See you then. Thanks a lot for all the speakers and for you to listen.